I'll get started here just as we have, I'm sure, more people coming in, but just get going on introducing and some background information. So hello to everybody. Welcome to the 7th session of the 2021-2022 Learning Exchange Series. I'm your host today, Kylie Clay. I'm the Associate Director of the Forest Carbon and Climate Program at Michigan State. We are very pleased to host this Learning Exchange Series in partnership with the Forest Climate Working Group. So the Forest Climate Working Group is a diverse group of forest interests with over 60 members, including landowners, industry actors, conservationists, academia, and those active in carbon markets. So the group has worked together for more than a decade to advocate for state and federal policies that work to ensure sustainable forest use and prevention of land use change. You're now seeing the full year's lineup of speakers. We'll drop a link into the webpage, to the webpage in the chat in just a minute, so you can check out all the speakers in more detail, as well as, of course, check out those presentations, those discussions that have already happened, both this year and previous. So this year we have 3 major thematic bins: voluntary carbon markets, changing as 1, 2, changing landscapes of climate and forests as 2, and the 3rd, which we are starting now, emerging science and information. So on our ORL, you can, as noted, you can watch recordings of those webinars that have already taken place, both this year and in previous years. For today's presentation, I'd like to introduce Maureen Putman, Director of Operations at CORM, that's the Consortium for Research on Renewable Industrial Materials, and Indranil Ganguly, an Associate Professor of Environmental and Forest Sciences at the University of Washington. So their presentation today is called Recent Findings on Building Scale Carbon LCAs and Demand-Driven Landscape Impacts. So today's session, as noted, is the first session falling under the Emerging Science and Information category. We are very, very happy to have these speakers here today and are really excited to get a look at some of this new and innovative research on the impacts and potential of mass timber. So, noted, we're very excited to begin, but before we do, a few details, a few housekeeping details to share. So first, to automatically receive registration details and information regarding upcoming webinars, please email forestc@msu.edu to join our mailing list. This session is being recorded and will be posted online, along with supplemental resources such as the presentation slides in the next week or so. So if you've registered for this, you'll receive an email letting you know when and where to find those materials. This session, as our other sessions, will be followed by Q&A. So we will let the presenters speak, and then in the remaining 15 minutes thereabouts, we'll strive to have a Q&A with our speakers. On the bottom of the Zoom interface, you'll see both chat and Q&A options. So within each, you can ask a question at any point during the presentation, and we will collect those questions and pose them to our speakers in the Q&A slot there. And if you are listening in on the phone, but you can't have a chat, but you can email, go ahead and send your questions to forestc@msu.edu. So we'll compile all questions and, time permitting, hope to ask them at the end. So a couple of other things. Attendees today are qualified to receive 1 CFE credit from SAF, and this will be automatically communicated to SAF, and you'll receive credit if you've registered, so long as you've registered your information with your SAF account. So if you have any questions about this, do reach out to us. Again, forestc@msu.edu. And that's all the housekeeping stuffs to discuss at the moment. So with that, Maureen and Indranil, please go ahead and steal the screen away and begin today's presentation. Thank you.
Hey, thank you, Kylie. And thanks to all of you for attending this meeting. I will quickly share some information on a special issue that came out recently. The special issue hasn't been published yet, but individual papers are. And you're seeing on the screen the actual special issue on mass timber and sustainable building construction. The reason I'm showing it to you, because both the presentations, the one Maureen would be doing and the one I would be doing, there are papers in this special issue, and there are other papers which feed into some of my, the information I use in my talks. So if you go down, you'll see the list of papers. Oh, the first one is by Kylie there, who is the host for today's presentation. Excellent paper. Thanks, Kylie, for submitting it. I read it. A really fun paper. We have mass timber construction in Chile, which Maureen was part of, but it was led by Chilean researchers. We have some UW research on sustainable timber sourcing in the United States, Chinese research, but the one I wanted to show is this one, a comparative LCAs of conventional and mass timber buildings in regions with potential for mass timber penetration. That's the presentation that Maureen would be doing, and Maureen is the first author on that. So if you want more information on the presentation, feel free to come here, download this paper and read it. It's free. And then the presentation I'll be doing, a section of it is from this particular paper, with Prakash Nepal is the first author. And that has to do a global mass timber demand and where the wood will come from. So, so these are the two papers that are directly relevant to these presentations. There are others that are related to mass timber. So I will post it online, and then I'll stop sharing, and Maureen would be the first one to present, and I'll be the second one to present, and we'll take all the questions together. Thank you very much. Maureen, go ahead.
Thank you, Indro. You made it easy for me. I could remove a slide after that great presentation. So I assume everyone can see the slide and not the presenter's view. It's always an important question to ask. Thank you, Kylie, and your staff there in the Forest Carbon Climate Group on inviting me today to talk about this work. This is a great opportunity to show what we have found. And when I use the word we, I really mean a great team of experts that were part of this study. And it was great that Quorum had an opportunity to be involved. As Kylie said, I am the Director of Operations of Quorum. Some of you might not know who Quorum really is, and we are the Consortium for Research on Renewable Industrial Materials. We are a 501c3 nonprofit established back in 1998. Quorum currently is represented by 24 board members and 20 institutions or associations within North America. Our current vice president is Indro, and the University of Washington is the institutional member. So we're happy to have him on board with us. For over 24 years, we have published over 60 third-party reviewed LCA reports on forestry operations and wood products and biofuels. Quorum also played a very integral part in the latest wood environmental product declarations that I assume many of you have seen or even used. We call ourselves the go-to place for wood LCAs, so I welcome you all to visit the Quorum website, and every publication we have produced is there for your download. I'm going to go back to some basic LCA for starts, and that is really the foundation for any whole building LCA begins with the results that either come from a life cycle assessment or an environmental product declaration of a product. And in the case of wood, those materials are usually developed using a declared unit, such as a cubic meter. This slide on the left, I want to point out, is just a summary of the materials and how different they can look depending upon how they are presented. So this figure on the left shows the amount of wood fiber used per volume of wood. So basically it's the density of the wood product. And for those of you familiar with wood products, you can see we have one solid piece of wood and the rest are engineered wood products, and they all contain resins, and depending upon how much resin and how much they're pressed, they're going to have a different density, therefore a different weight. So this is how they can look if you're comparing the different EPDs. But we also can present data as a functional unit, and that is the figure on the right here. So assemblies, such as foundations, exterior, interior walls, floors, roofs, whatever, they change the way the material is presented from a unit volume to the amount of wood used in a unit area. In this case, I'm showing you an interior wall assembly. And here you can see that there is a large amount of wood used in a CLT wall versus the standard light frame construction. And I really like showing these two slides because from a resource use perspective, you can really see, and it really emphasizes the relative amount of resource we use in our, or potentially can use in these buildings. In the case of using mass timber as a structural component, we should really be thinking about using CLT where it can displace other materials such as concrete, not where it is displacing where we can build with a standard wood frame construction. So in last month's presentations, in this webinar series, there was featured scientists from the Nature Conservancy, and they presented results and information around a 5-phase research project. The results presented today in my talk are exclusively from phase 1. This phase included a team of LCA experts, building engineers, architects, and our mission was to present comparative life cycle assessments on functionally equivalent mass timber in conventional buildings that are produced and used in Europe, China, Chile, and the US, as Indra pointed out in those publications. We were to report on the embodied carbon and the carbon storage of mass timber utilization at the individual building level. And as Indra pointed out, we have 2 publications that are really part of this talk today. The first one is filled with all the results, and I do welcome you to go to that because I just touched on one of the impacts in this presentation, and that's carbon. But of course, there's other impacts involved in the life cycle assessment that are presented, as well as energy use and so forth. So please, I welcome you to go to that to get more of the results. And the methodology and the data quality and the building plans are highlighted in this methodology paper. We're all pretty much the same authors, just a little flip-flop on who took the lead on that. But Hong Mei wrote a great paper on the methodology of this research. So my quick version of the methodology is the phase 1 team, which helped in the design of the buildings and develop the LCA models. We developed 2 different building types, mass timber and concrete, that were functionally equivalent buildings. And that, I think, is a real key element in our study, that we were able to have those designs by the architects, and they could just go and be put in place if that was what someone wanted to do. So we designed these buildings to be placement in 3 potential mass timber market areas in the United States: the Pacific Northwest, represented by Seattle, Washington; the Northeast, Boston, Massachusetts was where the buildings were placed; and in the Southeast in Atlanta, Georgia. The buildings were designed at 3 different heights: 8, 12, and 18 stories. Each building had a different foundation. The 8-story, a spread footing, a mat footing for the 12-story, and in the 18-story, piles in a spread footing. And I know you're probably not going to remember that, but remember that so for when you see the results. So they each had a different foundation. The system boundary that was included in this study goes from the extraction, so the A1 phase, all the way through construction. For those not familiar with these modules, A1 is the extraction of all the upstream production processes, so that's where forestry would be included. A2 is the transportation of those resources to the production gate. Obviously the manufacturing of the product, and A4, the transportation of the final product to the construction site, and then installation energy. And I also want to point out here, because I realized I hadn't mentioned any of the slides, that when I refer to mass timber, it is referring to both cross-laminated timber, CLT, and glulam. So right into the results. As we were commissioned to report embodied carbon, here you have really the overall results of a whole building, the embodied carbon analysis for the 8, 12, and 18-story buildings from all 3 regions on the left, and that's for mass timber, and on the right is the concrete building from the Pacific Northwest, the Northeast, and the Southeast. Here we have the measurement of embodied carbon represented as a square meter, but built off of the whole building. So just some highlights from this one: the Pacific Northwest concrete building, the 12-story building in the Pacific Northwest, had the highest embodied carbon per unit area. The reason for the highest in the Pacific Northwest was mostly attributed to the fact that it had to meet Pacific Northwest building codes for seismic protection, as well as, again, the 12-story building had the mat footing foundation, which tended to show a little bit higher impact over the other foundations. So, but here's the highlight: the equivalent 12-story mass timber building from the Pacific Northwest had a 44% reduction in the embodied carbon, and it too was designed with all the seismic codes that were necessary. And overall, the 8-story building showed the largest reductions over the equivalent concrete results, and those were in the 40 to 50% reduction range. To really show that how that looks, scaling it to the concrete building, on the y-axis is the percent the timber building contributed to the carbon emissions, referenced to a concrete building, which is placed up there at 100% line. So basically, in general, embodied carbon per unit area increased with building height. So we can see in all 3 regions. In the mass timber buildings, and this is because the concrete increased in these buildings as you got in the heights. The metal components increased, and other non-renewable, other non-renewable materials also increased. Reductions in embodied carbon ranged from 50% in the 8-story. But what I really want to point out here is the 18-story buildings compared to the 8 and 12, where we see very little difference between the 8 and 12-story buildings per square meter in their contribution, but we have that big jump in the 18-story buildings. And I'm going to talk more about the 18-story building a little bit later. This is just a teaser. Regional differences, I'm not going to spend too much time on those now, but just to highlight that there are regional differences. And we're going to throw those back on the electricity grid use differences, the species differences, and the transportation of the material, the final material to the building site. So just going to tease you with that at this moment. So this table shows the embodied carbon by life cycle stage. And this is for the Northeast region only, I'm showing here. Oops. The embodied carbon of the mass timber building was greatest in the A1, A3. This is the extraction and the production stage. So this would include forestry, resin production, transportation of resources to lumber manufacturing, and then the manufacturing of the CLT and so forth. So not a surprise to see the largest impact coming from A1 to A3. And the concrete buildings, this was as high as about 95% in this. But one of the most interesting findings, personally, I think, is when we start talking about the A4, when we're able to bring in the A4. And in the A4 transportation for mass timber buildings, this is taken from CLT production to the building site, it represented around 10% average here over, depending upon the building height, compared to concrete, which is just hovering around 1%. So that to me was a real wide awakening. And I was thinking about that, and I live pretty close to an interstate, and I'm sure many of you travel on interstates quite frequently. And have you ever seen a concrete truck traveling on the interstate? And your answer is probably, well, no. So the concrete production facilities are many, which means it puts them very close proximity to most building site that you want to choose anywhere in the United States. So where our CLT plants are not so globally or regionally located, and as well as lumber manufacturing, which would come in the A1, A3, transporting to those CLT sites. So, so I think it just really highlights something about where we build these buildings and where the CLT plants are located at this stage and the growth of CLT as a building material. So we also broke it down to not just look at the whole building, but to look at the assemblies. And we had assemblies broken down to columns, exterior walls, floors, foundations, interior walls for both the mass timber and the concrete designs. The example I'm showing here is for the southeast buildings. On the y-axis is the % contribution of each assembly type. On the x-axis is each building type for all three heights, the 8, 12, and 18-story building. And the main takeaway here is on the 18-story building, mass timber building. The interior wall, shown right here, represents in the southeast region 54% of the total embodied carbon of that whole building. So seeing that, it's like, wow. I thought, well, what is going on in the interior wall? So the table on the right breaks down that interior wall for the 18-story building. And we should note that the gypsum wallboard, we did use both an interior and exterior wall systems, but there's an exceptional amount of gypsum wallboard used in the 18-story interior wall. So within this interior wall assembly of the 18-story mass timber building, gypsum wallboard represented about 29% of the mass and 30% of the embodied carbon. And if you look a little higher up in the table under concrete, you see that their contribution to the whole building embodied carbon is just about equal, where the composition by mass of concrete is twice as much. And that is a real aha moment, if I want to call that. And so you probably want to know, well, what's going on with the gypsum in an 18-story building that we don't see in the other heights? Well, gypsum is used for fire protection. And as a result of strict fire codes, the 18-story building required 11 times more gypsum than the 8-story building and 2 times more gypsum than the 12-story mass timber design. So you're probably saying, well, we got to fix this. Well, how do you fix it? Well, I'm not a material science expert and don't want to be at this stage in my life, but I think looking into alternative materials besides gypsum, and also possibly the need to update and improve research and testing so that maybe building codes and materials that we need to use to meet the building codes actually reflect the actual risk that is at hand. So just a real quick peek at the other regions in case you're curious. They all were pretty much representing the same trend where that contribution to embodied carbon just about equaled the concrete contribution. So coming back to regional differences, besides electricity grids and transportation distances, I want to point out that it's really the lumber production process that is driving the impact of mass timber. And you can see that here in the lumber global warming potential, which is the embodied carbon for the lumber production. And these are values that are pulled from the EPDs or LCA reports. And they're primarily driven by the fuel used to dry the lumber. And, you know, for those who know wood, wood is produced at a very, comes to the mill at a pretty high moisture content, and that needs to get dried down to about 12 to 15% to go into CLT as well as just making structural lumber. And it takes a lot of energy to remove that water from the wood. And so the type of fuel that we use to dry lumber is driving this embodied energy in this. I should point out that these values do not include the emissions from combusting biomass in order to dry the wood. This is strictly based from fossil fuel use. So I also want to note that when we are solely relying on the environmental product declarations to tell us about the embodied carbon of a product, and when in fact we are interested in the embodied carbon of a building, we are missing that piece of the story, which is the A4. So again, this is the kind of information you get from the EPD, and you're saying, oh well, heck, let's look at the Northeast CLT production because their lumber production is so low. Well, would you really want to take that risk with the impact of A4 by transporting Northeast CLT to Seattle, Washington? So that's just my cautionary warning out there. Okay, so also as part of the mission of phase 1, we had to look at carbon storage. So we have seen that mass timber buildings produce carbon emissions during their production installation. Those were the embodied carbon results I showed in all the previous slides. But these can also be used, the storage, that can also be used to offset these emissions as buildings are used. So on the y-axis, we have the embodied carbon of the whole building. So this is not per square meter, this is whole building. And on the x-axis, we have the building types in each regions. So the green bars are the carbon stored in the product. The orange bars are the embodied carbon of the mass timber buildings. And the blue dots are the embodied carbon of the concrete building. So we don't have a green bar for the concrete building because they don't store any significant amounts of carbon. So in all 3 mass timber designs in all regions, more carbon was stored in the building than was released during production and installation. And that's just the takeaway that we see in pretty much every wood product out there. So summary, there are many, many opportunities for reducing embodied carbon in buildings. One of them is including and improving choices of materials. We can do this through building design, even though I didn't even touch on this topic, but starting at the foundation type, efficiency and use, waste reduction, and location of the building. Update and improve research and testing, so building codes and materials actually reflect the risk. Reporting clarity around the calculations used in whole building LCAs. And this is through communication and education and how to better harmonize results in reporting amongst the different LCA software tools. Reproducibility, transparency, consistency in the data is the key to acceptance of the use of wood in these type of buildings. We should also do our best on using local wood resources to reduce the transportation impacts, improve the service life, not just through design, but modifications, not complete replacements to keep up with codes, etc. Circling back to building design, we need to design for destruction. So materials, primarily the wood, can be reclaimed, reused, recycled. Using renewable fuels to reduce the embodied carbon through the entire supply chain. And we are just at the beginning to understand the full potential for wood buildings in a global carbon economy. The opportunities for lowering the embodied carbon of wood products and buildings are endless. And once we understand the substitution benefits, potential for long service lives, the reuse, we will then know the full potential of wood buildings as a carbon mitigation strategy. So I think I just mentioned all this: lower embodied carbon, substitution benefits, long service life, and reuse to enhance, to make that happen. All right. Thank you. For a full suite of LCA product reports, please visit the Quorum website. Papers are related to the talk. This is the link. And I hope I haven't put you all to sleep like my 5-month-old puppy is constantly doing. Again, thank you. And I'm going to stop sharing and give it to Indro.
Hi, guys. Thank you, Maureen. That was awesome. What you're talking about putting people to sleep. It was really exciting. So I will, let me quickly share my screen. So my talk, I'll primarily talk about global demand of CLT. We, in the papers, we showed that we are trying to see this embodied carbon, which is basically the fossil emitted either building a traditional building or building a CLT building, how those compares. And we did that for a few countries around the world. Now we wanted to see where we can see some of the demand over the next 40 years and how much CLT demand can we expect going forward, or and then where will the wood come from? So first I'll cover the mass timber demand study. I do say global, but we actually did some of the East European countries on the left-hand side. You see that we, West European countries, Austria, France, Germany, Italy, Netherlands, Spain, and UK. These are the countries we covered in our study. We also had US and China because of China being a big potential country. Some of the Asian countries we did not include with big potential is Japan. Is definitely a country we would include next time, and India may be coming up as one of the users of mass timber. The Latin American countries we included Argentina, Brazil, and Chile. The housing type, we did not use houses that could be built with stick frames. So it's multi-storied, even when it's residential, is multi-storied residential. We divided into 3 categories: less than 6-storied, 7 to 12-storied, and more than 13-storied buildings, and also non-residential, the same height categories. The third aspect is the 2 different types of mass timber that got used in this constructions. As Maureen mentioned, CLT and glulam. So glulam, generally, most of the beams and columns where glulam was used in the models I have used, and then CLT went in the structural wall, floor diaphragm, roof, and miscellaneous structural uses only, not the non-structural. I will show you an app later on. These are the countries that are covered, and this is the 2060. And I have a few scenarios: optimistic, conservative, and extreme mass timber use. This just shows the countries that we covered in this study, and the gray are the countries that are not included in this study. I know this graph is a little bit difficult to see. I will kind of try to train your eyes. First, look at the conservative estimate on the left side. The leftmost is the conservative estimate, and the lines indicate the adoption rate. So on the x-axis, we have years to 2025 to 2060. And on the y-axis, you have the adoption rate from 0% to 60%. That is the, in the extreme case, it went a little bit over 60%. So what it says that what is the adoption rate going forward with CLT? What percentage can I anticipate or expect happening over the next 40 years, 2020 to 2060? Now, the line with purple squares over here, this line is for the Western Europe. Now, what we see, the CLT adoption is already high in Western Europe, and given we have already seen a trend and the government and the industry acceptance, so that reflected in the higher adoption rate in Western Europe. Within the conservative estimate, by 2060, my model shows it can go a little bit over 40%. US is the second. We still have a low adoption rate in the US at this point. However, within a conservative scenario, my model shows a little bit over 20% adoption of all buildings within those heights I mentioned. Third is Latin American countries, the green triangles there, and the red circles represent China. So China in the conservative scenario is the least adoption rate, and there's good reason. For example, oriented strand board structurally used got never adopted in China. China produces a lot of OSB, but doesn't use it for structural use at all. And so if we take that, those and a number of wood structure use, China never adopted any of those, whereas Europe and US are the highest adopters. All those kind of went in. So you now see three scenarios. The optimistic is the middle one. The conservative is the left one. In the optimistic scenario, US comes close to 50% adoption by 2060 of CLT versus traditional. Europe goes up to 60. And in the extreme scenario, the jump happens primarily with the Latin American countries and the Asian country, in this case, China. The jump in Europe is relatively smaller. Now, I won't explain this. There's a lot of dotted lines. Again, purple is here for Europe. There are different adoption rates for different building height types and different residential versus non-residential. The top one is for residential, non-residential. The bottom one is for building height types. I will not explain this in detail, but this were fed into my overall adoption curves, which I'll show next. So here, what you see here are 6 different graphs. And so basically 3 sets. On the left-hand side, you have the orange and the teal color. So the orange color is non-residential and the teal color is residential. And this is for US only, okay? This is for US only. And in the conservative scenario, what we see that which is the top left, this one, conservative scenario US, what we see is the wood use, because of this adoption, the mass timber use would go up to around 2.6 million cubic meter by 2060, 2.6 cubic million in the conservative scenario. Most of the adoption will be happening in the non-residential sector than in residential, because we don't build a lot of tall or multifamily houses in the US. This changes when we go from US to Europe or China, where a lot more non-residential is built with or multifamily non-residential. On the right-hand side, these 3 graphs you see, these are by building heights. So if you see the top bar is orange is for building height 13 and higher. The middle one, the green bars are for 7 to 12, and the blue is for 6 and lower. So it's the same projection. One is by building type and residential, non-residential. One is by building height, taller buildings versus medium versus shorter buildings. Now, as we go down, we have 3 different in each category. So in the extreme scenario, we can expect somewhere around 9 million cubic meter of CLT adoption or mass timber adoption by 2060 in Europe, in US only. In the optimistic scenario, this is around 6 million. So that's how I'm reading the curves. I'll just show China in this case. The China conservative scenario, the adoption rate is really low. And as you can see on the top, 2 graphs are really low adoption. So in a conservative scenario, I'm not expecting that China would be a huge adopter. However, in a extreme scenario, if China adopts only with even 30% adoption, China's consumption of mass timber can go way over 35 million cubic meter in the extreme scenario. And in the optimistic scenario, it will be around close to 10 million cubic meter, which is pretty high, higher than US in both the optimistic and extreme scenarios. I'm not expecting the extreme scenario to play a role in any of the scenarios, any of the regions, but it could. And if you want to look at other countries, I'll show an app where you can go and look at other countries individually. Moving on, and also one more thing, you can see that the non-residential plays a bigger role in China. A residential plays a bigger role in China than non-residential, and China does build a little bit taller buildings. So if you look at the bottom two graphs, here, the residential, non-residential, the orange one is pretty high on the left-hand bottom side, and on the right-hand bottom side, you see that the 13 and higher is pretty high as compared to that what you see in the US over here, which is very minimal there. So this is just how different countries around the world build. So what we see is, and this is just the overall global demand, global based on these 13 countries. I'm expecting a 57 million cubic meter of wood demand increase just because of, in extreme scenario, just because of mass timber constructions. In the optimistic scenario, that's 24 million. And there's a huge jump between optimistic and the extreme scenario. And most of this jump actually comes from the top line here, which is China. In China, a little percentage increase is a huge, because China's tall building starts or multi-family building starts are way more than any other country in the world. And if they start adopting, it's huge adoption rate, as you can see in the top. Latin America can come up really fast, but US and Europe are, you see US going up to 9 million or 6 million, depending on the scenario. Europe is 5 or 6 million, depending on the scenario. Now, if you're more comfortable with board feet and not cubic meter, you can multiply or divide any of this number by 1.6. Where you'll get the million board feet of wood used. Now, internet may say cubic meter to board feet conversion is divided by 2.35. As I tell my daughter, never believe anything you find on internet. So because there's nothing 2x4 about 2x4. So that's why we cannot do a proper conversion. We'll have to factor that in. So if you look at and then there's a lumber to CLT conversion of 1.2:1. So 1.2 tons or cubic meters of lumber go and to make 1 cubic meter of CLT. That's because of some of the compression things Maureen talked about. Also, there's a lot of end cuts and that goes away while manufacturing CLT. And then there's a 2:1 logs to lumber ratio on an average. So when you factor all those in, that 54 million or 57 million cubic meter translates to 140 million cubic meter of log demand increase in the extreme scenario. And again, I'm saying in the extreme scenario. Now, where will the wood come from? I'll quickly talk about this paper, only 2 slides. Don't worry, I'll be done in 2 or 3 minutes here. This is the paper by Prakash Nepal. I'm a co-author, and Craig Johnston actually did the forum model, and he was at University of Wisconsin as a faculty. Now he's in Canada. So what happens because due to this demand increase, so we can expect a little bit of price increase that would happen, and a price increase means again, there's a downward pressure, downward movement on the demand because of the price elasticity. So the gray line here you see is the business as usual. As we are growing, all economies are growing. So the wood price is likely to increase, and that is given by this gray line here. Now, the dark line on the top, that's the extreme scenario price increase. The dotted line in the middle is the optimistic scenario price increase because of this enhanced demand for wood. Now, so in the conservative scenario, the price increase is minimal. It's around 8 to 9% in the optimistic scenario and 26% in the extreme scenario. And the price increase tracks lumber and logs similarly. So now when we factor that price increase and little bit, so the net increase in demand of logs because of this CLT production in the extreme scenario is expected around 70 million. Now, how come it came from 140 million in my previous slide to 70 million? Because during this period of time, there's also projected growth in lumber production, softwood lumber production specifically. And if you see the history and the trajectories, softwood lumber production has been growing because we have more and more plantations and we are producing sustainably in a number of regions around the world. So the net increase in demand on new, just because of this CLT construction is around 70 million cubic meter of logs in an extreme scenario, around 10 million cubic meters of logs in a conservative scenario, and the optimistic is in the middle. So when you look at the global production of, and this is softwood log, the green bar is on the right-hand side is the world, just focus on this. This green bar is the global log production. And the additional production we need in the extreme case is 4.6% of the green bar. So only 4.6% of the green bar. But I would say it is highly unlikely we'll go anywhere beyond the optimistic scenario. So anywhere between 0.7 to 2% log demand increase we are talking about, even in a very good optimistic scenario. And even in the extreme scenario, which is absolutely bonkers scenario, it's less than 5%. And this red is the extreme scenario, the purplish blue is the optimistic, and the purple is the least scenario. Now, most of this, this is not, okay, so I'll move on to the next one. So here I have two sets of graphs. Now, one set is not visible, and I'll show you why it's not visible. The first set is the percentage increase. So the 4.2% increase shows up here on the right-hand side. And so it will come from somewhere, right? There will be a pressure on the forests. And here we are making that assumption that our forest coverage is not increasing. We are just using the existing forest. We are not managing intensively and all that, which is not, we know that which is not practical, because if the potato demand increases, more Idaho farmers plant potatoes, but if the forest demand increases over the next 40 years, we are not making an assumption that forestry will increase. But we have seen successful afforestation programs in New Zealand, in the US, in Canada, and all over the world, a number of places in the world. But anyway, so even if you don't consider that, this is this, so most of the demand increase, percentage demand increase happens in Asia, as we see in the extreme scenario, globally is around 4.32%. Now, why don't we see any of the reds? The reason is the reds are there, but they're really tiny. Now you cannot even see them. Now, when I scale it up, now I blew that portion, the dotted portion there. And now now you see that there is anywhere between the carbon decrease in the land due to this, without any assumption of intensive forest management, any assumption of is around 0.15%. So 0.15 is a very small percentage, even in the extreme, in the worst case. And globally, it is around 0.03%. So very, very small percentage of carbon reduction in plant in land, but the huge percentage. So if you convert that 0.03% of land mass increase, afforestation, that should be our target. And then we can get the benefit of this mass timber constructions without even talking about carbon reduction in plan. And this is highly achievable, unlike the Trillion Tree Program, which Maureen co-authored a paper on. But this is highly plausible, attaining that amount of afforestation and offsetting that carbon reduction in the forest. I'll stop my presentation. That's me. If you have a question, you can shoot me an email. I've provided you an app. I mentioned that you can go to this app. If you click on that app, it will take you to a program here where you can find each countries. If you're interested in, let's say, Chile, you'll see what the Chilean production or estimate is over time, let's 2025 to 20. And then you'll get the numbers here, which you can download. In case of US, you do that and you get the US. So again, thank you very much for listening. I'll stop sharing the screen and I will leave the rest of the time for Q&A. Thanks.
All right, thanks very much to both of you for your very interesting presentations. We've had a series of questions come in, and I'll say a couple of questions have been answered in the chat, and so in the interest of time, I won't go over those again, but if folks are interested, I would say there's been an interesting dialogue about embodied carbon and what specifically is included in that. So do look at the chat dialogue there for those questions. So a couple of questions on the study and decision making and sort of what's going into that and numbers here. So Maureen, to your study first, one question about product reuse, in particular steel. So when you're looking at different products and the emissions associated with different products, a lot of steel is reused, 80 to 90% in some cases, right? Their estimates. So when you look at the emissions associated with products, are you looking at, how do you factor that in?
If we were to take this to deconstruction and reuse, that would be considered in that equation. So whatever would be for both a concrete building, let's say, or a mass timber, we would look at what's coming out of that building and how, what's the pathway for all the materials going in there. I don't know of any real data on any of that yet. Mass timber is it's done this as far as how quickly we've been building with it. But I know some researchers at OSU are looking at the deconstruction and what materials can come out by doing surveys to engineers and builders and stuff. So, but yes, it would be considered, absolutely, on whatever the pathway is.
Okay, so just a follow up, and so when you have steel in your buildings, are they considered to be reused steel materials, or is that?
I'm going to have to defer you to Hong Mei's paper, which shows you what processes we used. I don't know what % recycled steel was in those processes that we used. Okay. I can't, off the top of my head, I don't remember.
Fair.
and within the LCA that we used, recycled steel is part of the overall steel mix, given the US average. Now, I think what Maureen is mentioning that I also don't remember the exact percentage of recycle in the US, and it changes by country, but we did use recycled steel or whatever the existing mix is in the LCI we used.
Okay, great. Thank you for that. Another question, Maureen, for you also, is concrete buildings. Note that concrete buildings last longer than timber buildings. How, if at all, was lifespan taken into account here?
We did not go or do the carbon accounting, at least in the paper I presented here, to that. And I actually might even disagree with concrete buildings lasting longer than wooden buildings. I think most buildings are deconstructed before they structurally need to be. It's more of an aesthetic thing and new in there. And certainly we have nothing on mass timber buildings on how many years they're gonna last out there. So it's all so new.
And based on some of the studies that we have seen and weathering studies is CLT building by any way does not show to have a lower lifespan than concrete buildings or any way to dispute that. Yeah.
Okay, thank you. A couple of questions, Indra, for you on the study. First, quickly, the adoption rate that you're reporting on, is that an annual rate of adoption?
Yeah, Rick, thanks for the question. It depends on if you're using the annual data, it can be annual. It's just the adoption rate, it's a rate, and it can be used with monthly data or annual data, but I modeled it based on annual. So basically for let's say 2025 or 2028, no matter which month's data you use, you'd use the same rate for 1 year. So yes, I model it annually, but if you want to use monthly data, you can use it with monthly data, and the rate would be same.
Another question, Indra, for you is regarding the countries that you've chosen as to be part of this study. You noted in particular that Japan and India would also be interesting to look at. So 2 questions. One, what led you to choose the countries you chose? And then follow up, why not these other important countries? And also, why are they important countries? Why do you expect heavy demand there?
Yeah, that's a good question. And that's something we struggle with. So a lot of it came from the funding agency interest. They wanted to look at China. They wanted to look at US. And then I picked the West European countries based on their existing. I wanted to create a diversity of countries in there. China with the least adoption potential, with Europe, West European countries the highest, and the Latin American countries. I don't have a good answer why I did not choose Japan, because I should have. At that point, we wanted to make sure we can finish the study. But that's a good question. I don't have a good answer. All I can say, stay tuned. I'm working on the Japan one and a few other African countries and India if possible. So hopefully those will come online.
Excellent, looking forward to that. So last question, we are at time. Just a very last quick, if mass timber is so great, right? Why is it taking such a long time to get picked up? Why are even the exceptional adoption scenarios not very high? I've read even elsewhere that it can be less costly even to produce and to construct a mass timber building. So what's the holdup? What's the barrier?
Maureen, do you want to take it?
I'm not in marketing or in engineering, but I'm going to say cost is probably a big driver, and I think acceptance. I think there's enough cautious folks in the wind out there because it has grown. I mean, think of how many years we've been building with steel and concrete, and the confidence we have in those buildings. And now someone's saying we can build, 20 stories of wood. It's like, no, you can't. But so I think we just need to do the education and the outreach and have the sound testing, and money needs to be put into that, so we can show that transparency and show that confidence in those buildings. It's just, yeah.
And why it did not play a big, why it's so slow. So it based on the wood, and to all the builders and architects out there, the wood products in the building construction industry in the US and around the globe is the slowest to adopt an innovation. We have seen 20 years for OSB to be adopted before it became a structural product that's adopted in the US, in Europe 15 years, in China 40 years, and no adoption of OSB as structural material. So there's no indication that wood products industry and the building industry is bonkers and are very in adopting innovative wood products. Because of obvious reasons, we want to be cautious when building a house. And so that all played a role in there. And I'm saying extreme scenario, we have never seen a 60% adoption of a innovative material in the history of building construction. So unless it displays the previous one altogether. So those are all factors that played a role.
Excellent. Well, thank you. I won't keep anyone longer. I know we're beyond. So really thank you, Maureen and Darneel. Really appreciate you taking the time to talk with us today. Fascinating studies. And to everybody still on there, as a note, the reminder, the presentation recording and supplemental slides will be online and you'll receive that update. So thank you, everybody. And I hope you have a lovely afternoon.
Thank you.
Bye, guys.